Hello, my name is Leona Annabelle, and for experiment F, my unknown was number 603, and this is what it looks like. It had a very dark brown, kind of reddish tint to it, and this is my final structure. I also have it on PubChem. This is what it looks like. And the way I came to this conclusion was first I knew the molecular weight was 137, so I used the rule of 13 to calculate the base formula, and the base formula I found was carbon 10, hydrogen 17, and since the molecular weight was odd and the calculated HDI was a decimal, I knew that there needed to be a nitrogen in the formula. So as you can see, there are a few variations I tried. With mixing one nitrogen and oxygens, two oxygens, but the final one that I came to a conclusion was this one. Carbon 8, hydrogen 11, nitrogen, and oxygen. And the way I came to this conclusion was not only using the molecular weight, but also by inspecting the IR and the NMR. So first with the IR, I noticed that there were aromatic overtones and around the 2000 mark, and this helped a lot because that I knew 6 of the carbons would be used for that. And then there was a very large peak around 1500, which was potentially carbon-carbon bonds, and then a one at 1200, which was a carbon-nitrogen bond. And there were very small peaks around 3,400 and 3,300, and that indicated that a potential amine group was in my formula. And then I looked at the NMR, and this is what it looked like. And as you can see, there were 1, 2, 3, 4, and 5 different independent peaks, which signified that there were 5 unique hydrogens in my formula, or in my compound. And so since they're really spread out and the peaks are really small, I'm gonna show you this one first, or these two. This is what it looks like. And although there is a lot of complex splitting occurring in this peak, or these 2 peaks, ultimately it is 2 peaks. And the way I knew this is because I already knew there was going to be an aromatic ring in my my compound from the IR, and so this is in the correct location to be the hydrogens of the aromatic ring. And when I did my integration, I calculated the centimeters of each of the peaks, these 2 and these 3, and I came to the conclusion that these 2 peaks both had 2 hydrogens each, which indicated that it would be an aromatic ring with 2 substituents and 4 hydrogens, which makes sense. And so I did know that the formula of the hydrogens were going to be in this way, because both of these peaks were, it mainly had like 2, and there was a lot of complex splitting, but they did look symmetrical. And when you look here, these 2 are the same in terms of symmetry down the middle, and these 2 are the same. And I continued on with the other peaks, starting with the easiest one. This very small singular peak was around 3.4-ish, and I knew that was these 2 hydrogens because there were no neighbors, and they were in the correct location to signify for an amine. If you look on this, it is around 3-ish, and that is where an amine would be. So that's how I came to that conclusion with this one. And again, when I integrated it, it gave me 2. So it matched up perfectly. And then for this one here, at 4, the camera's not focusing. Okay. At 4, I know this one was this carbon that was next to an oxygen, because when I integrated it, it had 2. And when you look at the chart, there are 4 smaller peaks, which indicates that there are 3 neighbors. And that matches up perfectly with this methyl group. And last but not least, the methyl group that I just talked about is here on around the 1.4-ish parts per million, and it's a triplet, which means there are two neighbors, and it matches perfectly. And when I integrated, it said that there were 3 hydrogens, which means it's a methyl group, so it fit perfectly. And so this is how I came to the conclusion. Another thing that really solidified that this is the correct formula was that when I looked it up on PubChem, if you recall, this is what my sample looked like. It was a very dark, kind of reddy brown color. When you look here, it tells you that the physical description is a colorless to dark red liquid. And so as you could see from the picture, mine was a dark red brownish liquid, and it matched up quite nicely, and it has the same molecular formula. So I do believe that this, with the chemical formula of C8H11NO, is my compound. Thank you.